Hi grade 9s, I'll be looking at factorising sums and it will be a revision, so you've done all of this before. It's just a few examples so that you'll be able to just remember how to complete the worksheet that we will be uploading onto our website under worksheets and resources. So when factorising, you have a few different types. So firstly, we will be looking at a highest common factor, then we're going to be looking at some fractions, and then some dot sums, so difference of two squares, and then highest common brackets that we will take out or factorize out. So for the very first one, it's very important to always take into consideration all your terms, not just one of them, but all of them. So when you look at the very first one, you will see that you have 4a and you have positive 2. So you need to look at both. You can't factorize something out or take something out if not all your terms have that specific number or variable. So when you look at 4a and then you look at 2, it's always a good idea to look at the numbers first. So you have 2 and 4. So maybe first write out all your factors for 2. So it's 1 and 2. And then write out your factors for 4. It's 1, 2, and 4. Now the highest common one they both have is 2. So you can actually take out a 2. So you can factorize out a 2. So I'm going to write down the 2. And then once you've looked at your numbers, now you can actually concentrate on your variables. Now you will see that only 4a has a variable a. 2 doesn't have a variable even. So we will not be even taking out the variable, because if the one term has it and the second one doesn't, you can't take it out. Both the terms have to at least have one of the variables. So I'm only going to factorize out a 2. Then I'm going to create brackets because something will be left over if I take something out. So what I like to do is I like to write down what I have. So I have the 4a and I'm going to factorize out or take out or divide out a 2. So now just a little teeny tiny fraction that you need to simplify, and you're going to say that 2 divides into itself once and into 4 twice. So the only thing you have left over there is a 2a. Then the second part, again, I like to write it out. I like to say you have a positive 2 and you're taking out a 2. 2 divides into itself once and into 2 once. So you have a positive 1 left. Now, this is then your answer. But you can always check if you're going to get full marks or something like this. So you can, just in your mind or quickly with a pencil, you can say 2 times 2a is 4a. And 2 times positive 1 is positive 2. Is this answer then the same as your question? If it is, you know that you have full marks. So it's just a nice way to check whether you're getting it right or not. So now we can look at the second example. So for the second example, you will see that you have 3 terms. So you need to take all 3 of the terms into consideration. So you will look at the negative 4p squared, the negative 20pn, and the negative 4p. So just a hint or tip, if you start with a negative, so your very first term, this is your very first term. If your very first term starts with a negative, take out or factorize out a negative. Okay, and then you can look at the numbers. So you have 4, 20, and 4 again. So you can write out your factors, 1, 2, and 4, 1, 2, 4, 5, 10, and 20, and then 1, 2, and 4 again. So now you can quickly check, have a look at those. The highest common factor is 4. So already you know that you can then factorize out or take out a 4. Then you can look at the variables. Now, only the first one has p squared, the second one has 1p, and then the third one has 1p. So the first one has 2, the second one has 1, and the last one has 1. So the most you can take out from all of them, which will be the same amount, is just 1p. You can't take out p squared if only one of them has p squared. Then, when you look at the ends, only the second term has an n. So if the first and third one doesn't even have an n, you can't even think about taking out or factorizing out an n as well. So the only thing that you can actually take out is negative 4p. And then you create your brackets because something will be left over. So now again, and you don't have to do this, but I found out that it kind of helps me a bit. Just write it out. And then later on, you won't actually write it out because you already know what to do. But sometimes first writing something out will help you get the concept. So you had negative 4p squared, and you're taking out a negative 4p, or factorizing out or dividing out a negative 4p. And now you can just simplify this a bit. So the negatives completely divide out. 4 divides into itself once and into the top 4 once. P divides into itself once and into p squared only once, so you have 1p left. So the only thing you have left for the first term is 1p. So then for the second one, you had negative 20pn, and you're dividing out a negative 4p. Again, the negatives cancel out, so you have a positive left. 4 divides into itself once and into 20 5 times. The p's cancel out, and then the n can't divide out or cancel out with anything else, so it will just stay n. So you have a positive 5n left. And then for the last one, you had negative 4p, and you are dividing out a negative 4p. Now, these ones are always interesting because you think that nothing will be left over, so you would like to put a 0, but that's not true at all because the negatives cancel out, so you have a positive left already. The 4 divides into itself once and into the top 4 once, and the p's completely divide out. But you don't have 0 left, you have 1 over 1, which is 1. So then that is your answer. Now, you can again check, and you can see that negative 4p times p is negative 4p squared. Negative 4p times positive 5n is negative 20pn. And negative 4p times positive 1 is negative 4p. So you're just checking that you're getting full marks for these ones because it's not that difficult. So let's now move on to a fraction. So for the fractions, try and treat them separately. So maybe just look at your numerator and then you try and figure out your denominator. So don't let it freak you out. In fact, pretend that that part isn't there. Okay, so when you look at the first part, 4y plus y squared, there's no number that you can take out. So you can then directly go to your variables. So you can actually take out a y. So I'm going to take out a y, I'm going to factorize out of a y, and something will then be left over. So again, you can write out, you had 4y and you're dividing out a y. The y's divide out, so you only have a 4 left. And then you had a positive y squared and you are dividing out a y. One of the y's divide up with one of those y's, so you have a positive y left. So that is then your numerator part. And then you had 16y at the bottom there. So now what you're looking at is the fact that, okay, you have one term over one term. So if you have one term over one term, you are allowed to then start dividing out. But you are not allowed to work inside this bracket over here. You're not allowed to cancel something from the bottom and from the top within the bracket. So just don't work into that bracket. So I always pretend it's like a house. You're not allowed to just go into someone's house and take things. So pretend that a bracket is like a house. You can't just go into that person's house and take something. So from the outside part here, outside the bracket, you can work with that. So this y divides into itself once and it divides into the bottom y once. So the only thing you have left is a y plus 4 plus y over 16. But don't start dividing out this 4 with this 16. Okay, and the reason for that is you have two terms over one term, and then you are not allowed to divide out. You're only allowed to start dividing out or cancelling out when you have one term over one term. So in fact, you can keep these in brackets because again, that same rule applies. You are not allowed to go into a bracket and take something from there. So your answer is literally only y plus 4 plus y over 16. Okay, now we can look at some dot sums, and these are actually quite nice to work with. You just need to look at 3 things. Check if you have literally the words of dots. So difference, do you have a difference sign? Yes, you do. Do you have 2 terms? Yes, you do. And can you get the square roots of each? Yep, you can. So if you actually can say the word dots in your head and say difference of 2 squares, do you have a difference sign? So that's the minus there. of two terms, you have two terms, yes, and squares, can you get the square roots of them? Then you know that you can actually apply dots. So with dots, you need to create two brackets first, put a plus in the one and a minus in the other one, and then you can find the square roots of each of those terms. So what's the square root of x squared? It's x times x, so it's just an x. So for the first bracket you put an x, and for the second bracket you put an x. Then for 64, what's the square root of 64? It's 8. So I put an 8 in the first term and an 8 in the second term, and that's then your answer. For the second one, for number 5 over here, just check again if it's dots. Now, before you can check if it's dots, always try and take out a highest common factor first, if it's possible. So when you look at 2y squared and negative 8, is there something that you can actually factorize out number-wise? So when you look at the 8 and 2, the highest common factors is 1 and 2 for 2, and it's 1, 2, 4, and 8. So your highest common factor for 2 and 8 is actually 2. So you can actually factorize something first. So let's take out a 2. Now if I take out a 2 again, if I had 2y squared and I'm dividing out a 2, the 2's divide out with each other, and I have y squared left. And if I had negative 8 and I'm dividing out a 2, the 2 divides into itself once and into 8 4 times, so I have negative 4. Now, when you look at the bracket now, is that maybe dots? Let's check. Do you have a different sign? Yes, you do. Do you have two terms? Yes, you do. Can you get the square root of each of those terms? Yes, you can. In that case, you carry your 2. Your bracket splits into your two brackets because that's what you do for dots. One of them gets a plus, one of them gets a minus, and then you're going to get the square root of each of those numbers or terms. So what's the square root of y squared? It's a y times a y. And what's the square root of 4? It's a 2 times a 2. And then that is your answer. So always first check if you can take out a highest common factor. So for number 6 over here, I can't take out a highest common factor, but I'm going to check if it's dots. So do I have a different sign? Yes, I do. Do I have two terms? Yes, I do. Can I get the square root of each of these terms? So even though you might not think it, you can actually get the square root of x to the power of 2, of 4. The square root of x to the power of 4 is x to the power of 2. X to the power of 2 times with x to the power of 2, I keep my bases and I add my exponents. So it's x to the power of 4. So I can actually get the square root of that. So immediately you create your two brackets, one a plus, one a minus. So then you get the square root of each. The square root of x to the power of 4, we just looked at this over here. It's x squared, so an x squared in each bracket. And then the square root of 16 is 4, so 4 in each bracket. But when you look at the second bracket over here, that is actually also dots because I have a different sign, I have two terms, and I can get the square root of each. So carry your first bracket because that is not dots, and the reason for that is you don't have a different sign. But this highlighted one over here can actually split into its own two little brackets because it's dots. So plus in the one and minus in the other one. The square root of x squared is x, so x in both brackets, and the square root of 4 is 2 and 2. So that is then your answer. Now we will be looking at taking our highest common bracket. So again, it's the same thing as for the first ones, it's a bit more complicated. So you have one term and you have a second term. So when you look at these two terms, they actually have a whole bracket that looks exactly the same. So with the other sums, you took out a number or a variable. Now you're going to take out a bracket. So write down the brackets. What you then did was you actually created another bracket for whatever would be left over. So let's think about this. If you had 2 and then x minus 3 in brackets and you divided out, so factorized out the x minus 3, do you have one term over one term? Yes, you do. So you then are allowed to start dividing out. So I said that you're not allowed to go into a bracket, but you can divide out a whole bracket. So you will see that this whole bracket is the same as that whole bracket. So I can actually say this whole bracket divides into itself once, and it divides into the top one once. So the only thing you have left is a 2. So the same with the second part. If you had negative y, x minus 3 in brackets, and you're dividing out an x minus 3, you will see that you do have one term over one term. This whole bracket is the same as that whole bracket. So this bracket divides into itself once and into the top one once. So you have negative y left. And that is then your answer. You can actually check, and if you were to distribute over here, you will actually get to your question. So again, you can check if you're going to get full marks or not, or if you did this correctly or not. But for the second one over here, number 8, it is a bit different. So you will see that, okay, again, you do have your 2 terms. Okay, so you're going to take both your terms into consideration again, but the brackets aren't completely the same. So if they're not exactly the same and it's something to do with like the signs, there's going to have to be a sign change. And the sign change you always apply to the second part. So keep your first part exactly as is, and then you change the sign of the second one, but only in front of the bracket. So that plus, I'm going to make a minus. So if it was a minus, you'll make it a plus. So once you do that, the 2 then stays there. But what's going to happen is the inside parts will also change. So this was a positive 3, so now it will be a negative 3. And this was a negative y, now it will be a positive y. So what you actually do now is you will see that these 2 brackets are actually exactly the same. Okay? I'm just going to rewrite them a bit so it looks better to my brain. So this is still x and then y minus 3 in brackets, minus 2. So the negative 3 I'm going to keep at the end and the positive y at the start there. So now you will see that, oh, okay, they look exactly the same. So now we're back at this. It looks exactly like sum number 7 now. So the whole bracket they have in common, so I'm going to take out a whole bracket. So the y minus 3, and then something will be left over. So I had x and then y minus 3. I'm dividing out or factorizing out a y minus 3. Again, I do have one term over one term. So this bracket cancels out or divides out with that bracket. So it goes into itself once, divides into the top one once. So only have an x left. And then I had negative 2 y minus 3 over the y minus 3. Again, they are exactly the same. I do have one term over one term, so I can actually say that this bracket divides into itself once and into that bracket once. So now I have negative 2 left. So then this is your answer, and it's just one more step, this little step here of changing a sign, and then you back to the sum of number 7 as well. So it's not that difficult, it's just one more step that you need to apply, and you do that to the second part of your sum, so the second term. And there will now be a worksheet under resources for you, so you can follow the link and you can go and try these. There's also a memo for you, but first try them without even looking at the memo, work through these examples, concentrate when I'm talking, and then you will surely be able to do the worksheet and practice a bit more.